Thank you for catching that. Good morning, and this is Simplifying Radicals Part 2. So if you have notes in front of you, we're going to pick it up from page 15 in your packet. For those of you that are watching online, I am going to be writing everything that I want to convey to you. Unfortunately, when the notes got scanned into the document, they got scanned in the wrong way, and we're having some technology problems. So I'm just going to work through it with you. So the other day, if you listened to the first part of the lesson, we talked about simplifying radicals, and we told you that there were two methods. So let's go ahead and look at an example here. If we want to simplify radical 72. So method number one would be prime factorization. So we can prime factor 72 to 2 times 2 times 2 times 3 times 3, because 72 breaks down to 8 times 9, 8 breaks down to 2 times 2 times 2, 9 breaks down to 3 times 3. So now we're looking for pairs. I have a pair of 2's and I have a pair of 3's. Or we could say it's like saying 2 squared times radical 2 squared times radical 3 squared times radical 2, which would be 2 times 3 square roots of 2, or 6 radical 2. Method number 2 would require you to look on page 5 of your packet, which lists all of the perfect squares. And you are taking out on a date the greatest perfect square. So the square root of 72 would break down to radical 36 times radical 2, or 6 radical 2. Now I know for some people that method 2 at this point might look easier, but when you're doing these problems, remember there's no calculator to be used, and if you don't know the perfect squares, that's really going to hold you up. So in my opinion, I think at this level where we are, prime factorization is the way to go. Does anyone have a question? Okay. So if you go ahead and go to page 17 in your notes, let's look at another example. The square root of 48. The square root of 48. Let's break 48 down. Who wants to help me break 48 down? Anybody? Go ahead. 6 and 8. And 6 goes to? 2 and 3. And 8 goes to? 2 and 4. And 4 goes to? And so that would be 3 2's, excuse me, and 1 3. Or my final answer here would be what? 4 radical 3. You all with me? This is just giving you more and more opportunity. All right, let's go to page 21 in your notes. I know I really spread these out for you. And let's go ahead and simplify 40, x to the 4th, y to the 5th, z to the 3rd power. Okay? So we want to go ahead and we want to prime factor 40. Goes to 5 and 8. 8 goes to 4 and 2. 4 goes to 2 and 2. And then we prime factor all of the variables as well. So it's 3 2's, a 5, 4 x's, 5 y's, and 3 z's. And so now we're playing Go Fish. We're looking for our pairs. We're circling our pairs. We have a pair of 2's. We have 2 pairs of x's. We have 2 pairs of y's and a pair of z's, which would give me 2x squared, y squared, z. Is that correct?
Yes.
2x squared, y squared, z. And everything that's not circled stays under a 2 times 5 times y times z, which should be 10yz. Is that correct?
Yes.
And there's your answer. Remember we said it's not necessary that you put anything. You'd never have to use absolute values. Okay? All right. Let's try it. Go ahead. You can flip the page again, going to page 23. If we want to simplify x to the 11th power, x to the 11th power. So I'm going to give you a little hint here. We know that x to the 11th, remember, the square root, let's just go over here for a minute. Let's see if this helps you. The square root of x squared is what? X. The square root of x cubed would be x square roots of x. The square root of x to the 4th would be x squared. The square root of x to the 5th would be x squared radical x. Does anybody see a pattern? What's happening? What's happening when the exponents are even? There's no radical, good, and you're just taking whatever this is under the radical, dividing it by 2, so the square root of x to the 4th would be x to the 2nd. Are you catching on to a pattern here? So the square root of x to the 6th would be what, guys? X. The square root of x to the 7th would be what? X to the 3rd radical x. The square root of x to the 8th would be x to the 4th. The square root of x to the 9th would be x to the 4th radical x. And the square root of x to the 10th would be x to the 5th. So basically, when you're given something under a radical like x to the 11th, you're trying to find the largest even exponent that makes up x to the 10th. So do y'all agree that would break down to x to the 10th times x, which is x to the 5th radical x. Of course, if you didn't see it, you could write them all out and circle your pairs. Are there any questions? Okay. All right. We're pretty good on time, so let's just try. Let's go to page 25 in your notes. Page 25. This is not actually awful that we did not. We already did all of these? I'm recording, guys. All right, so why don't you guys go ahead and do that real quickly. All right, guys, so we are trying to simplify these quickly, and then we're going to switch gears and we're going to talk a little bit about multiplying and adding and subtracting radicals. So we'll look at that in a minute. For those of you that are listening online, I hope that you're going along and doing these problems with us. Again, this is page 25 in your notes. And this whole packet here is basically on, up to the next page, this is basically on just simplifying. Okay, so who can simplify radical 8 for me? Radical 8 would break down to 2 times 2 times 2, or what, guys? 2 radical 2. Radical 20 would break down to 2 times 2 times 5, or what? 2 radical 5. Radical 32 would break down to 2 times 2 times 2 times 2 times 2, or 4 radical 2. Square root of 75 would break down to 5 times 5 times 3, or 5 radical 3. And radical 40 breaks down to 2 times 2 times 2, 5, 4, 2 radical 10. Anybody have a question? All right, moving on and having fun. So now we are on page 26, using the product property to multiply. Using the product property to multiply. Okay, so this is page 26 in your notes. And if I want to multiply the square root of 3 times the square root of 15, I'm using this rule. The square root of a times the square root of b is equal to the square root of ab. Square root of 3 times the square root of 15 equals what? The square root of what? The square root of 45. Here is your big hint and asterisk. You must try to simplify. You cannot leave it as radical 45. And the reason you can't leave it as radical 45 is you're not sure. Can radical 5 be broken down? So what you have to do is you have to prime factor to see if this can be simplified further. So radical 45 breaks down to 5 times 9, and 9 breaks down to 3 times 3. So this would break down to 3 times 3 times 5, or what, guys? 3 radical 5. Do you understand? Yes? All right, so let's try this one. You try this one. The square root of 2 times the square root of 6. Square root of 2 times the square root of 6. So when you multiply under the radical times under the radical, and then you're going to go ahead and you're going to see what you have, then you must simplify it at the end. We're going to simplify at the end. All right. So what we're doing here is we are multiplying radicals. We are on page 27 in your notes. And so I would like for you to, let me just go back for a minute and show you the one that we just did. Okay, so we have this property that we're using, the square root of a, anything under a radical times something else under a radical equals the product of the two of them. So the square root of 3 times the square root of 15 would be the square root of 3 times 15, or the square root of 45. Now, the most important point that I can give you right here is that you can't leave your answer as radical 45, just in case radical 45 can be broken down, which it can. So when you prime factor it, you get radical 45 equals radical 3 times 5, or 3 radical 5. So now we were going to try to break down or to simplify radical 2 times radical 6, which equals radical 12. We all know that radical 12 breaks down. What did you guys get for an answer? 2 radical 3 is correct. Okay, what happens if we want to go and do something like this? 2 radical 6 times 3 radical 8. Multiplying radicals. So here is your rule. You multiply the outside times the outside. Then you multiply inside times inside. And you simplify. You simplify what's inside if it can be simplified. So let's just show you what I mean by that, and we'll take a quick look. You ready? So you're going to multiply outside times outside. So 2 times 3 gives me what? 6. And then you're going to multiply radical 6 times radical 8, which gives me 6 radical 48. Now we all know, because we simplified radical 48 before, that radical 48 can be prime factored, right? it breaks down to 8 and 6, or 2 times 2 times 2 times 2 times 3. 16 times 3. So this would be 6 times 2 times 2 times 2 times 2 times 3. So who's coming out of prison? How many 2s? So you're going to multiply everything that's outside together, and who stays in prison forever? The 3. 6 times 2 is 12, times 2 is, and your answer is 24, radical 3. Are you with me? Are you sure? All right. 7. $28 I already covered. We're in good shape. All right. I'm going to end there for today. Thank you so much for listening online, and we hope you have a great day and happy spring break, everybody.